All right, so now we're at the next part of chemical reactions where, okay, now we're going to actually start writing them and predicting them instead of just telling you what they make. And the first type that we're going to do is a synthesis reaction. So synthesis is what it sounds like. You're synthesizing something, you're making something. And if you look it up in different books, they also sometimes call it a composition reaction. So it just depends where you go or what your professor likes to call it. It doesn't matter to me. One thing here is, the big thing here is you only get one product. So most of the time synthesis are really simple, so we'll show you examples of the simple ones. Then we'll show you there's 5 weirdos you have to watch out for, and then we'll practice them. But realistically, it's just starting to become aware of patterns, and there's lots of patterns in chemistry, and just really seeing, okay, what does this have to do? So the simplest type of synthesis is the ones where you have just 2 elements. So if you look here, there's lots of examples. But you have an element, which is rubidium, you have an element that is oxygen. The only 2 things they can do is either they're going to do nothing, and they'll just sit there and there would be no chemical reaction, which is not that exciting, or they're going to stick together. So what we know is we know rubidium would have to stick to oxygen. Now, you don't have to memorize all these like group 1 metals form oxides with this formula. All you have to remember is you have to balance your charges. Rubidium's a +1, oxygen's a -2, so when you stick them together, you just write the appropriate formula for it. So it's not bad. Honestly, the trickiest thing is making sure it is synthesis and making sure you don't forget all your Brinkelhoffs and your weirdos. If you look down here, we have barium plus sulfur. So element plus element. Only thing they can do is stick together. Barium's +2, sulfur's -2, and then you go back and you balance. So the steps to this are going to be, you're going to figure out its synthesis, you're going to predict your product, you're going to write the balanced equation, and then you go back and balance the whole big shebang. Here's just some more examples here. We have iron 2 reacting with oxygen. We have iron 3 reacting with oxygen. Now, on the test or whatever, I would have to tell you which one it would be, or you could choose either. So it's if they can have more than one charge, then you have to be indicated that. Down here we have sulfur reacting with oxygen to make sulfur dioxide, and that kind of stuff. So really, element, they stick together. I think there's even another one. Yeah. So a couple more. Element, stick together. Element, stick together. So again, not rocket science. You're looking for a pattern here. Now there are some weirdos, and that's what we're going to look at the next 2 slides. And then really when you're doing these, you need to stop and think, okay, is it one of these easy, nice ones? Or is it going to be one of the slightly more complicated weirdos? So we'll mark the weirdos. The first one right here, this is your first weirdo you have to worry about. A metal oxide reacts with water, and it will produce a metal hydroxide. So this is an example where calcium is our metal. So calcium oxide plus water makes calcium hydroxide. But the trend will always be the same. If this calcium was barium, if this calcium was potassium, if this calcium was any other metal, same trend. Second one here is another metal oxide with carbon dioxide makes a metal carbonate. So again, here's one with calcium, metal and oxygen plus CO2, and we get a metal carbonate. Down here we have the exact same thing but with rubidium as opposed to calcium. So metal oxide, CO2, metal carbonate. Always the same. Down here you can have non-metal oxides produce oxyacids. So we have this sulfur and oxygen are non-metals. Reacts with water, and you get this guy right here. One nice thing you might want to write down with this one is they self-balance, which means no coefficients. So basically, they only use what they have. Like he had 2 hydrogens, so we have 2 hydrogens. He had 1 sulfur, so we have 1 sulfur, and we had 3 oxygens, so we have 3 oxygens. 2 more weirdos. We have metal oxides and non-metal, SO2s form sulfites. And this is a salt one. This isn't that much of a one. I don't think we really focus on this one, but it is one that's in your book and you can look at. And then the last one here we have metal chloride and oxygen makes a metal chlorate. Now again, should you know these? Yes. am I realistic and think that maybe you just want to write them on your note card? Sure. What you need to be able to do is pick them out, and when you see them, apply them. So we'll practice on the next slide, and then you'll practice again, and then you'll have homework with it. But you should be able to pick these out. So these are our lovely ones here. So we're going to practice one. And the first one, we have sodium plus oxygen. And I'm telling you, these are synthesis, so you have to think, is this an easy one where it's just two elements, or is it going to be a weirdo? So this first one is just two elements, so he's going to be an easy one. And we'll actually just go through and do that first and then kind of come back. Second one here, we have metal oxide and CO2. That's not just two elements, so this is probably going to be a weirdo, which means we're going to have to look at which one does it fit. Third one is nitrogen element, oxygen element, so it's going to be an easy one. Third one is copper, which is an element, sulfur, which is an element, so it should be an easy one. Fifth one here, metal oxide and water. Definitely not just two elements, so that's a weirdo. And if we look down here, we have a metal chloride plus oxygen. It's definitely not just an easy one, so this is going to be a weirdo. So once you can go through and determine what they're going to be, it's not as hard and not as overwhelming to figure out how they're going to do. So if we do this first one at the top here, we said there's going to be easy. That means that sodium is going to hang out with oxygen. Sorry, I don't know why I didn't write there. So Na, and it's going to hang out with O. You look this up on your blue sheet because this is an ionic compound. Sodium is +1. Oxygen is -2. So the formula we get for our product is Na2O. Again, you have to do that first. Don't worry about balancing. Just get the formula. So you have your reactants written. You correctly predicted your product. And then what you go back and do is you balance the whole big equation. So you say, okay, I have 2 sodiums on the right. I only have 1 sodium on the left. I have 2 oxygens on the left. I only have 1 oxygen on the right. You want to fix it. And what we're going to need is we're going to need 2 of the Na2Os, because that'll give us our 2 oxygens. That'll give us 4 sodiums. And we are correctly written, correctly predicted, and balanced. Next one is a weirdo. You look at your trends. Metal, lithium is definitely a metal. Metal oxide plus CO2 gives us a metal, which is, our metal is lithium, carbonate. You gotta know what in the world is a carbonate. Carbonate is CO3. Balance your charges. Lithium is +1. Carbonate is -2. Predicted your product, which is awesome. Balance your equation, and this one's really nice because it's already balanced. So you don't even need any coefficients for this one. It's already done. Third one is an easy one. We have nitrogen hanging out with oxygen. Now this is a kind of a awkward one because when nonmetals get together, they can form lots of different things. The easiest thing to make this form is just nitrogen monoxide, which is something that does naturally occur. Remember, covalent things are a little different. You don't have to balance their charges as much. So if this was on the test, I would have to kind of give you a hint or accept a lot of answers. But that's a completely acceptable answer. And then all I have to do is balance my equation. Fourth one here is an easy one. So copper is going to hang out with sulfur. So we have copper and sulfur. Now again, look here. They're telling us it's copper 1. This isn't like some weird writing that they did here. They're telling you that it's a copper +1 charge. So this is copper +1. Sulfur is a -2. And that means we're going to need 2 coppers. Once you have written your thing correctly, make sure you go back and balance. I need 8 sulfurs. So I'm going to put 8. And that means I need 16 coppers, which is kind of crazy. Alright, the last two here are weirdos. Again, you're following your trend. Metal oxide plus water. You gotta say, what in the world does that make? You gotta go back and find it. It's gonna make a metal, which in this case is magnesium. Hydroxide, and you have to know what in the world is a hydroxide, which is OH. Balance your charges. Magnesium is +2, hydroxide is -1. And then again, go back and balance your whole big thing, which in this case is already done. So that's nice. And very last one. Metal chloride plus oxygen. It's definitely a weirdo. Look it up. We are going to make a metal, which is aluminum chlorate, which is ClO3. Sorry for my atrocious handwriting. And again, balance your charges. Aluminum is +3. Chlorate is -1. So we're going to need 3 chlorates. Now be careful here because we have 9 oxygens, which is a weird thing. So what we're going to have to do is double the 2 aluminum sides. And then we're going to need to put a 9 out front of our oxygen. And we should be good to go. So, you need to practice this. Make sure you do the classwork, make sure you do the homework, and make sure you get them all. Because this is not something you want to mess around with, because this is the first of all the different types.